Hello and welcome back to part 2 of the square column drill press build. If you haven't already seen part 1, be sure and check it out. Well, let's get started. Okay, I milled the surface of that right there to be square with that. Held it in the vise like that and milled the surface. Now I know these two surfaces are square. This is going to be my bracket for the upper part of the lift screw. So it's flat up against the back jaw of my vise. Now the bearing is 2.44 inches in diameter. The bearing on my slide, the back of the slide. So I want to go half that distance to here, because that'll be the center of my lead screw, and that's where I'm going to mount my bearing tube. It'll be clear when I get to it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Drilling a hole big enough for that. That mill's not quite big enough, but I'll use a fly cutter after that. Enlarge the hole. Too fast. That's better. That's a pretty good fit. Would have liked it a little bit tighter, but it'll work fine. I'll weld that pipe in there, drill a couple holes right there, bolt that right there, and this bearing with a piece of shaft that'll screw into the shaft to be right there. Big bearing in the bottom too. Yeah, I think that'll work out pretty good. That's it. Yeah, there's my ugly weld. I'm getting a little better at it, but boy, I screwed up there. But it'll hold. My bearing fits on the bottom and the top. Let's put that together. Fairly snug fit, but it works. There'll be a axle in there with a threaded hole for the lead screw, or the lift screw, whatever you want to call it, and a sprocket up here. I was going to put the sprocket in between, but this should work good. Proper tension on those bearings ought to work good. I did some things off camera here. I put a snap ring groove in the bottom of the shaft here, made a spacer, goes on there, it sits up against the snap ring. Oops, goes like that. That goes into my lift screw bracket. The other bearing goes on the top there. And on the top, this key goes in there. A little bit snug. And then I threaded the top of it. Put a 1/4-20 bolt in there. There we go. And as I tighten that, it tightens my bearings. It forces the sprocket down. Okay, that's a little bit tight right there. Tap that keyway down, or key. Just a hair tighter. Okay, that's too tight. Feels about right. Once you get that set, you can lock the sprocket on the shaft. And then snug this down just a hair. Of course, I'll put grease in the bearings. Then on this end, I was going to put the threaded rod in there and then pin it. But if I do that, then I can't, it'll mess up the threads and I won't be able to take that rod out if I need to. So I made this coupler. And that'll screw on there. I'll probably put a lock nut on it. Maybe even Loctite it, I don't know. And then I'll drill and pin that right there. And the reason I want to do that is it'll act like a flex coupler. The alignment won't be real critical. These threaded rod, they usually have a bow in them. So if the threaded rod wobbles a little bit, it won't bind up. And that'll allow me to unpin that and remove this threaded rod if I need to. So I guess the next step is to mount this. Okay, I got my threaded rod in here. I got it set, this is set to the maximum height I would need. So, and every drill press will be different. This right here will bring my table up to about chuck level. So that's more than adequate. Should probably put a square on that. we go. Put a nylock nut on it. It's just acting like a big cotter key. Ready to go. There we go. There's that problem I'm trying to fix. Well, that's probably not very good for a drill press. These bushings are a little bit long. I'm probably going to hit in the middle. Yeah, it didn't go quite all the way down. That right there is going to be my tension arm for the hand crank for the drill press. It'll be clear when I get it mounted. Okay, all I could find in the right size sprocket was a 3/4 inch bore. So I cut a key in that 3/4 inch bore, and now I'm going to turn this down so that it'll fit in that bushing, and that'll be our hand crank right here. Okay, I'm about 5 to 7 thousandths over, so I'll go with 2 thousandths, take 2 more thousandths off and check it again. I'm going to mill a little flat on there, give the crank something to grab. Might be better with a key, but flat's a little easier and I think it'll be adequate. Okay, there's my, what do you want to call it, mandrel or whatever, tension adjustment. Put a key in there. And that'll be my tension adjustment and hand crank for raising and lowering. Okay, level that way, and my 2 sprockets are level this way. So I'm ready to transfer my holes and drill and thread the square tubing. Well, it locks down good. That's good. I was a little concerned about that slipping right there. But I don't think that'll slip. It locks down firmly. So now I've got to put a chain on here. Probably make it just coming straight off of there. It's right here. Doesn't take much effort. I think a crank right here will move it pretty good. I thought about putting a motor on it, and I may do that eventually. We'll see how well it works with a hand crank. Well, there it is. I still got to grease the bearings there and put a hand crank on there. Hand crank's next. I found a piece of aluminum in my scraps with 2 holes already in there. I just have to enlarge this one, frame it to the shaft size. What did I do with my oil? Here it is. All that oil makes a mess, but makes that reamer last a lot longer. Now, I'll put a 1/4 20 set screw in there. Maybe 2 of them. 2 of them might be better. Isn't that something? Okay, I put a bolt on there temporarily. I'll come up with some kind of sleeve to go over that for a hand crank. Got a couple of set screws there, nut on the top, nut on the bottom. I got to put a washer on in there for clearance right there. Okay, drum roll please. You know what? I think I need to shorten it up a little bit. I'm going to leave it like that until I get the table on it. Additional weight of the table might change my mind, but that is really easy to turn. And having the shorter torque arm would make it a lot quicker to make a big move. I was a little concerned about that thread being too slow anyway. I could put a bigger sprocket here. I just didn't know how much effort it was going to take. Well, I've threaded the where the table mounts, and I got my XY table mounted to it. I'm going to use the screw to lift it up. Pretty heavy table. Should have made that out of hex stock. That way I could have grabbed it with a wrench instead of a vice grip. But this will work. It's not something you got to deal with all the time. One time, I think. But it's pretty important that it's tight, otherwise the table could fall if it ever came loose. Okay. Now, yeah, it's working pretty good. Now I can square the table up to the column. I cut threads about halfway through, so that bolt limited out in there. There it is, all done. My square column drill press. I'm pretty pleased with the way it came out. It really works nice. I've used it a few times already. Under here, it's got the this pin. It's on an eccentric. There's a hole right there. Loosen these bolts and you can turn that pin up or down and it'll push the bearings against the column and level the table. I've got it level, so I'm not going to move it. You just lock these bolts down and it stays put. Right here, it's a typical drill press mount. That's a, I think it's a 5/8 bolt, single bolt. You can loosen that and level your table or tilt it for drilling at an angle. I don't very often use that, but it's locked down in the level position now. Of course, I've got an XY table on there that I built. I'm not going to go into how I built that. That was made out of a lot of surplus parts that are pretty hard to find at any kind of reasonable price anyway. Right here, this bolt here locks it down. And if you don't lock it down, the table kind of wiggles a little bit, but after you lock it down, it's firm. So I'm pleased with that. The lift is going through the back pin that has the bearings, where the threaded rod is. That's 13 threads per inch, so one turn on that rod raises it 1/13 of an inch. And up here, got the lift mechanism, and the sprockets are 1-to-1, so one turn on the crank is 1/13 of an inch. In other words, the table moves 1 inch for every 13 cranks. My torque arm here, it was kind of, I didn't know how much effort it would take, but I ended up shortening that to about 2.5 inches. That makes it fairly fast to raise and lower, and it doesn't require too much effort. I may eventually put a motor on it. That'd speed things up and make it more convenient. This area right in here, I ended up getting pretty darn close. You can see my motor mount's just about touching that 4x4. It doesn't matter because I never moved the motor mount, but that's something to be aware of. I probably should have cut that down more of an angle to give me more clearance. But in this case, it's not a problem. I will probably draw up the plans for this part of the drill press, maybe the stand, and kind of leave this up to whoever might want to build their own. This is going to be different according to what model drill press you have. This column here was 2 3/4 inch. A lot of them are 3 inch or 2.5 inch. Just depends on what you got. But overall, I'm very happy with it. I got a lot of extra holes in here. That's just because it's surplus metal. But it's pretty simple, you know. It's just 1, 2, 3, 4, 5, 6 holes. well, more than that really, but it's not a whole lot of work to make. It's just really important that you do it accurately. Anyway, thanks for joining me. Be sure and subscribe.